Okay, hello Cloud Gurus and welcome to this lesson. This lesson we're going to look at network access control lists, or NACLs as I like to call them, versus security groups. So just a quick recap of what our environment currently looks like. So we've got an instance in a private subnet as well as an instance in a public subnet. We've deployed our NAT gateway. We've got two different security groups. One is to protect my private instance, the other one's to protect my public instance. We only have one network ACL, and this was created by default when we first provisioned our VPC, and basically it's allowing all traffic in and out by default, and that's why we can go ahead and access this. So our public subnet and our private subnet are actually associated to this network ACL. A really important point to remember in an exam is that you can only ever associate a subnet to one network ACL. You cannot have them associated to multiple network ACLs. So let's go ahead and have a look at our network ACL. Okay, so I'm on the VPC dashboard. If I go over to my network ACLs, I'll be able to see them in here. And then we'll be able to see my network ACL here. You can see that automatically it's been associated with my subnets, and this is my private VPC. My inbound rules and my outbound rules is allowing everything, so inbound and outbound. Amazon always recommend that you do them in increments of 100. Interestingly, they've done it at 101 for IPv6, so maybe it's increments of 100 for IPv4 and then increments of 100 for IPv6. We'll have a look at why we do that in a little bit. And we can see that the subnets are both associated with this one. So let's go ahead and create a new network access control list. I'm going to call this my web NACL, something like that. I'm going to deploy it into my default VPC. Straight away, it's just like security groups. Network access control lists can only be deployed into one VPC. They cannot span VPCs. Go ahead and hit yes, create. So that is going to go ahead and create it. Now, what do you think the default inbound and outbound rules will be for this one? Do you think they'll be open to the whole world, just like our default one that was created when we created our VPC? Well, no, it's deny everything, deny everything. So by default, when you create a private network access control list, everything is denied on both inbound and outbound, and that can be a very important point to remember going into the exam. Okay, so before I start playing with this, I want to be able to test it, so I'm just going to quickly log into my public web server. Okay, so I'm on my web server. What I want to go ahead and do is actually turn it into a web server, so I'm going to type in yum install and then httpd and then yes. And that is going to go and install my web server. What I'm then going to do is just start the HTTPD service. So service HTTPD start, and that's now online. And I'm just going to go over to my var www HTML directory, clear the screen. I'm going to do check config and then HTTPD and then on. So in case this reboots, it will start up automatically. Now all I'm going to do is go nano. And then we're going to call this index.html. So this is going to be our landing page. I'm going to write a quick little bit of HTML, just HTML, H1, and then hello cloud gurus, end H1, and then end my HTML. And go ahead and hit Control X to save and hit yes and then enter. So that has now saved. Let's just go in and test this. So just go over to EC2 and grab your web server's public IP address and paste that into your browser. Okay, and there we go. We can see Hello Cloud Gurus. Okay, so we're now ready to go ahead and test our network ACLs. Let's go back over to our VPC section. So what we want to do is we want to go in and customize this network ACL, and we're going to go in and allow certain ports to be able to access it. So if I go in and edit, I'm going to go ahead and add a rule. And we always want to start at rule 100. That's what Amazon recommend. Rule 100 for IPv4 and then rule 101 for IPv6. And then you go up in increments of 100. That way, if you need to add other rules in later, you've got basically the ability to change it 100 times before it starts to go wrong. So we've got rule 100. Basically, the first one I'm going to add is HTTP. So I'm going to allow HTTP. The source, I'm going to allow it from anywhere, so 0.0.0.0/o, and then I'm going to go ahead and add another rule. I'm going to continue to do this for HTTP, HTTPS, and SSH. So I'm going to pause the video and fill this out. Okay, so I've added in my inbound rules. You can see I've got the three allows here. So rule 100 HTTP, rule 200 HTTPS, rule 300 SSH. and then we're denying anything else both on IPv4 and IPv6. If I click over here on outbound rules, you'll see it's all deny automatically. That's because our network access control lists are stateless. So unlike security groups, with a security group, when we go in and provision a rule, that's allowing both inbound and outbound automatically. With network access control lists, it's you have to go and do it both. So I'm just going to go in and fill this in now, and I'm going to add another rule, and this rule is going to be rule 300. And with rule 300, it's going to be a custom TCP rule. And then the port range is going to be my ephemeral ports. So basically, we'll go through this in a second, but I'm going to leave that as is. And I'm going to go ahead and hit save. I should enter in my CIDR address range for these as well. So, okay, so there we go. I'm going to go ahead and hit save. And that has now saved. So let's just talk a little bit about ephemeral ports, just so you understand. So quick, if you want to look up ephemeral ports on Wikipedia, it gives you a pretty good explanation. So ephemeral ports is short-lived transport protocol, and essentially it's used for TCP, UDP, and SCTP as the port assignment for the client end of a client-server communication for a well-known port or of a server. So let's say I'm, trying to do a HTTP request to my web server. I'm doing that on port 80, but the information is going to be transmitted back to me on a random port. And there's a whole bunch of debate in the Amazon documentation. In fact, let's just go over to it. So if you just type in ephemeral ports VPC into Google, you'll be able to get this. But essentially, the client initiates the request, chooses the ephemeral port range. This range can vary depending on the client operating system. So many of the Linux kernels will use 32,768 all the way up to 61,000. Elastic load balancers, the old classic elastic load balancers, are going to use ports 1024 to 65535. For that reason, I've used that address range. Windows operating systems can use 1025 up to 5000, Windows Server 2003. It's entirely up to you what you want your ephemeral ports to be, depending on your own, security concerns. So I'm just going to make it as wide open as possible so that I don't have any issues later on. So 1024 to 65535. Which is what I've got in here. So I've saved it. I've got my network ACL all ready to go. Right now, though, it's not associated with any subnet. So let's go in and do a subnet association. And in here, I'm going to associate it with my public subnet. I'm going to go ahead and hit save. Once I do this, what's going to happen is a subnet can only be associated with one network access control list. So this subnet is now associated with it here. If I go over to my default VPC subnet, you can see that it's no longer no longer associated with my default network access control list. So let's go ahead and see if this has all worked. So what I'm going to go ahead and do now is I'm going to go over to my A Cloud Guru page and refresh the page. So here we are. Hello, Cloud Gurus. I hit refresh, and yep, seems to be working. Okay, so let's start having some fun, and we're going to learn about how rules are evaluated. So let's add another rule, and I'm going to add this as rule 101, and I'm going to basically take HTTP and I'm going to deny it to my specific IP address. So I've got my IP address from whatsmyip.org. It's a /32, and in here I'm going to change to deny. So let's go ahead and hit save. So how do you think the rules are going to be evaluated? Because right here I'm saying allow HTTP, and then here I'm saying rule 101, deny it to this specific IP address. Let's go over and refresh the page. Okay, so I'm refreshing the page and there's no issue whatsoever. And that makes sense, right? So rules are evaluated in numerical order. And the reason Amazon recommend, or used to recommend, I can't actually see it in the documentation anymore, but they used to recommend that you should do them in increments of 100, is that you've got 100 different ways to change your mind a bit later on. So why don't we do that? Let's change our mind and move this rule over to 99. So now I'm going to go ahead and hit save. Now this is going to, by default, deny HTTP to this specific IP address. So again, let's go ahead and refresh the page. So in here I hit refresh. You can see down here it says connecting, connecting, connecting. I'm telling you it's going to time out. And there you go, it has timed out. This site cannot be reached. And that was instantaneous. As soon as I applied that rule to that network ACL, it took effect immediately and it's now blocked me. So network ACLs can be really, really powerful. We can use them as a way to block specific IP addresses. We could block as specific IP address ranges. We can do a whole bunch of things with network ACLs. Network access control lists are basically, assessed before security groups. So by blocking port 80 to myself on rule 99, even though I've got a security group allowing port 80 to the world, it's my network access control list that's blocking me first. Security group doesn't even get to see this traffic because the NACL has taken care of it. Okay, so what are my exam tips? Well, your VPC automatically comes with a default network ACL, and by default, this network ACL allows all outbound and inbound traffic, but it's only the default network ACL that does this. When you go in and create your own custom network ACLs, by default, each custom network ACL denies all inbound and outbound traffic until you go in and add the rules. The subnet in your VPC must be associated with a network ACL. If you haven't gone in and associated a subnet with a network ACL, it's just going to use the default network ACL. You can associate a network ACL with multiple subnets. However, a subnet associated with only one network ACL at a time. So yeah, just like it says, you can have a network ACL and have multiple subnets attached to that, but your subnet itself can only have one network ACL at a time. When you associate a network ACL with a subnet, the previous association is removed, and we saw that in the lab. Network ACLs contain a numbered list of rules, and they're evaluated in order, starting with the lowest numbered rule first. We saw that when it was denying port 80 to my specific IP address at rule number 99, that was evaluated first. Rule 100 opened port 80 up to the entire world, but I'd already been denied. Network ACLs have separate inbound and outbound rules, and each rule can either allow or deny traffic. And then finally, network ACLs are stateless. So responses to inbound traffic are then subject to the rules for the outbound traffic and vice versa. So this is the opposite of security groups. With a security group, I could just open port 80 and then that was it. There's no way to use a security group to block a specific IP address. Do remember to allow ephemeral ports on your outbound rules. Do it on your outbound rules only. I messed up in my last lab and I did it on inbound rules, and then I had a whole bunch of people raging on the discussion forums. I actually got a really weird, threatening LinkedIn message from some guy who was like really passive aggressive about this error that I'd made on that lab. So sorry guys, I am only human. I do make mistakes, but we have fixed that now. So like I said, ephemeral ports, outbound rules only on your network ACLs. And then finally, just remember that you can block IP addresses using network ACLs, not using security groups. So that is it for this lecture, guys. In the next lecture, we're going to go and have a look at elastic load balancers with our custom VPCs. It's going to be really, really quick. So if you've got the time, join me in the next lecture. Thank you.